Thank you. Good afternoon, everyone. Good to see you here after lunch again. So yeah, today is going to be about vector search, my talk. So introduction to vector search, vector databases, and yeah, it's really an introduction talk. So what is it, why would you need one, and how you can use one. So first of all, I am Laura. I am a machine learning product researcher at Semi-Technologies. And at Semi-Technologies, we build the open source vector search engine Weaviate. So before I'm going to talk about vector search, I first want to take a step back and look at why we actually need a new type of database. So today we see a shift happening from keyword-based search to semantic search, which basically means that keyword-based search is search that is done by a traditional search engine, traditional database that uses, for example, a relational database to store data. But now with all the advances in machine learning, we've gotten used to natural language search and recommendation systems. So we kind of now expect from a search engine that we don't have to remember exactly the keywords of the data that we're looking for, but that the search engine will figure out what we mean. So let me illustrate this by an example. Let's say we have a database with some unstructured data, in this case text. So let's say we have a database of articles with the title and maybe the content with the actual text. And now we want to search through it. So we have, yeah, I just wrote down two titles here as an example. So how to build a REST API and programming languages for data scientists. Let's say you're a data scientist and now you're looking for an article about Python. Now, with a traditional search engine which works based on keyword matching, you might not find any results based on these two articles. And that's because the word Python isn't actually used in one of the titles or the content. And moreover, you might actually end up with an article that is about the snake python because it's the same word, but as a data scientist, this is not really what you're looking for. But now today we have like machine learning models, and with machine learning based search, you might actually find the correct result. And that is because machine learning models that is trained on the right data can understand the language that we're talking about. So it understands in this case that Python is similar to programming languages for data scientists. So that's one challenge that can be solved in machine learning. So let me rephrase this challenge a bit. So it's difficult to process, understand, and search through unstructured data. Not only text, but also images, videos, whatever. So this part can be solved with machine learning, like we saw. But there's more. So if we want to use this in production, we need a scalable and secure way to run this. And this cannot be solved with just using machine learning. You need an efficient data store for this. So let's first dive a bit deeper in the first part of the challenge and the first solution. So we can use machine learning to understand the context of data, unstructured data. Let's see how that works. So machine learning models, especially the ones for that can understand natural language or images, videos, what they do is they have you take a bit of unstructured data, and the machine learning model will run it through either neural network or some easier process. And the machine learning model basically represents this data as vectors. So vectors or vector embeddings are essentially just long arrays of numbers representing that data. You can also see it as points in a high-dimensional space, so coordinates. So let's take a look at this example. Here we have a three-dimensional space, and the data that is in here is represented by the coordinate, by the vector. So on the left-hand side, we have animals. We see a cat, image of a cat. You see that these two concepts are very close together. That's because the cat, an image of a cat, and a dog, they're all really similar in the semantics, really similar in the meaning and context. That's how a machine learning model also sees this type of data. And all these animals are far away from, for example, some piece of fruit, because they're not similar in meaning. So this is how most machine learning models process text or images and so on. So we have these vector representations, and now we can use this to perform search or data retrieval. So if you have this data set and you have a search query, which can also be in natural language, then the same or a different machine learning model can be used to generate a vector as well and look up in this high dimensional space which concepts are similar and retrieve that. So that is, basically what machine learning does in search. But now imagine you have this data set, but then with millions of data entries, or billions even. Also, now I pictured here three-dimensional space, but most machine learning models use hundreds or even thousands of dimensions. So memory this takes a lot of memory, of course. And for your application, you have many users, so you have many queries per second. So you need a high throughput. So this part of the problem cannot be solved with just a machine learning model. You need something that can scale the machine learning models, basically. So the question becomes how to search through it on a large scale. And here are a few more features that we need, a few more requirements. So first of all, to scale it, we want to store and retrieve the large amount of data and their vectors. So we don't only want to store the vectors, but also the data object itself, of course. Secondly, we want to have this machine learning model running in production reliably. And finally, we want also full-time CRUD support. So this is a feature that differentiates a vector database from a vector library. There are vector libraries out there that you can use to do this type of search on large scale. But in those libraries, you can upload your data once, and then you can read it. You cannot change the data anymore. So we need this data mutability basically to have it working in production. So full-time CRUD support. So for the second part of the problem that I started with, it's difficult to use machine learning models in a scalable and secure way. I believe that vector search engines are the solution, or vector databases. So what is a vector database then? It basically summarized what I just said. A vector database uses machine learning to store and index data, and also, so not only the data, but also the vector embeddings. And this allows for similarity search, and you can combine this with structured filtering. So you can not only do vector search, but because we have also the actual data object stored, you can combine it with the structured filtering that you're used to in SQL, for example. And finally, the full-time CRUD support. And a vector database can work this efficiently because it uses so-called ANN algorithms. So ANN stands for approximate nearest neighbor algorithms, which are used to do this on very large scale efficiently. So let me go over this step by step, how this search pipeline will work. So first of all, you can choose a machine learning model that you can use to vectorize your data. So this can be a neural network. For example, there are neural networks or machine learning models available on the internet. Popular ones are BERT models or sentence BERT models for text, or ResNet 50 models for images. And luckily today we have platforms like Hugging Face and OpenAI that have pre-trained models available that we can use. So we can use any of these models or your own trained model to vectorize your data. So the second step is then you can do a search, which will also be vectorized using a machine learning model. And then the vector search engine will do an approximate nearest neighbor search to retrieve the results that you want. So one example of an ANN algorithm is HNSW. I don't want to go too much into that, but basically what this does, it uses graphs and graph structures to and links between data to retrieve the most similar items to a search query in the most efficient way. And it's called approximate nearest neighbor search instead of KNN because it's approximate. We want this in a very efficient way. So this means we cannot reach 100% accuracy, basically. So now I want to go a bit more into Weaviate. Weaviate is one of the current available open source vector search engines that use machine learning to do this stuff. So this is how a search pipeline with Weaviate would look like. I'll go over it step by step. So first, as I said, you choose a machine learning model that is able to vectorize data. This is also called an encoder model or retriever model because it encodes data into a vector. So we can use pre-trained models that are available on the internet or your own model, for example. You have your own data. Unstructured data can be long text documents, can be images, videos, DNA, protein sequences, anything. Anything that the machine learning model understands, basically. This will be stored inside the vector database Weaviate. Then if you do a search query, this will also be vectorized using the encoder model or a different encoder model depending on your setup. And Weaviate will do the approximate nearest neighbor search to retrieve the list of results. This is how a very basic search pipeline looks like. So we have one machine learning model and we have the database. But Weaviate is modular. This means you can extend this pipeline as well. So you can, like I said, you can use out-of-the-box machine learning models to do this. You can use your own models, or you can use Weaviate as a pure vector database if you have your vectors ready already. And you can extend this search pipeline by, for example, doing something with the results that are returned by the database. So if you're building a question answering application, then you want to use a question answering machine learning model that can retrieve an answer from one of the results of Weaviate. So you can extend the pipeline however you want. So now that I hope that you have a basic understanding of how that will work, I want to go into, how do you then use it? How do you interact with this database? Weaviate is or ends at the API level, so it means we have API endpoints that allow you to interact with the data, of course. So we have, the usual RESTful API endpoints to do CRUD operations. That's not so exciting, but useful. And we have GraphQL API endpoints to do intuitive querying. And that's what I want to show you today. So we have 2 demos running live at any time. So if you want to try it out later on your own, you can go to any of these demos. So the first one is a small data set, 3 3,500 news articles, so that's relatively small, just to show you how it works. And secondly, we have a data set available with the complete English Wikipedia indexed. And that's about 25 million web pages, or like long articles. So yeah, this really shows you that this can work on scale, and that's also what I want to show you in the demo now. So what you see here is a graphical user interface of how you can interact with Weaviate. So on the left-hand side, I can make the queries. On the right-hand side, you can see the results, basically. So like I said, this is a database with Wikipedia articles. I index them per paragraph. So let's just see what's in there. I make a get query. I want to see paragraphs and the content maybe, and in which article they appear. So this is a graph relation to an article. So on the right, we see the results. So basically, this is now a list in random order, because I didn't do any machine learning magic here. I just retrieved some paragraphs from the database. So we can see here we have the content, and we have in which article it appears. So now let's add some semantic search. So let's say I'm looking for some articles about a certain topic, then I can do a near text search. So since we're in Berlin, I thought something Berlin related. Let's show maybe 5 results. So now I'm looking for paragraphs that are near the concept of high buildings in Berlin. And now the list of results is ordered by how relevant they are to the search query, so how close they are in this high dimensional space. And the first result is appearing in the article list of tallest buildings in Berlin. And you can already see here that the machine learning is working, because I'm looking for high buildings. It returns me something about tall buildings. So the machine learning model that I'm using understands that with high, I mean also tall. Second result is like a long article about Berlin. Third one is a list of tallest buildings in Germany. So here you can also see it makes the relation between Berlin and Germany. So yeah, that's pretty cool. So I can also change this to tall, I think, and comes up with the same result. And I don't know if you noticed, but I'm running this with 2,500 articles, and yeah, it's pretty fast. So this is a basic search, and like I said, you can expand this search or extend with question answering. So I can also ask a question here, and then Weaviate will look for an answer. So not only a data object, but also retrieves an answer from this data object. So let's ask, what is actually the tallest building? And with this parameter, I can also ask for the actual answer. So now I do not only do a similarity search, I ask a question which I want an answer to. And yeah, just one result here I asked for, which is found in this Wikipedia paragraph, and it found this answer. I checked it beforehand. This is the TV tower that you might have seen last few days. So yeah, I think it's the correct answer. Yeah, let's see how tall this building actually is. So how high? Yeah, so now it finds how tall it is or how high it is in this like long article. So yeah, this is basically how you can use Weaviate. And like I said, you can also connect. So this is using a machine learning model that is trained on like generally the English language in this case. But if you have a use case that is more in the medical domain or more in like any other specific domain, of course you can use a machine learning model that is specifically optimized or trained for that domain, so it also knows the specific jargon. Yeah, I have time to show another demo. So this is basically how you would use it at the API endpoint, of course. I have another demo how it can look in an application. So with image search or like combined search in this case. So let me start up the thing. So now I'm starting up a Weaviate container, which is already, there's already some data indexed in there. So this is using a multimodal a machine learning model that can process both text and images in the same vector space. So now I can look with words to images. So if I would do like, I think there is a dog in there. It shows me the dog with 62% certainty. If I would do animal, it will still show me this. Fruits, like it comes up with this, but also if I do like grape, which is more specific, it will still show me this result. So this, of course, done by this model, but we can use this on very large scale now because we use the efficient vector database. So yeah, I hope you get an idea now of what you can do with it. Then finally, I want to highlight that we are hiring. We are now a small startup with 20 people, and we're looking for people to help us building this great product. So if you're interested, you can talk to me afterwards. That's it. So thank you.